Next, I will introduce how you can resolve a triple fault. I inserted an intentional fault in my code, so it generates triple faults. And please have a habit of like a QEMU NOx if you are not confident with your implementation. So after getting the all correct result at the QEMU NOx, run the make grade. Then you can quit this like a control AX, yeah. And then to debug this, just use GDB. That's it. So run tmux, split the screen, then make QEMU NOx. No, not this. QEMU NOx GDB. Then it's wait for the GDB, run GDB on the right side. No. And then what you need to do is just continue. Then it says triple fault, yeah, and then it stopped exactly at the line of the code that we get a triple fault. So you don't have to analyze the bug. For like the where does it happen, GDB automatically find that for you. Yeah. So now we have the source code like this. Yeah. But this is not the source code that you wrote because it says like the function is memset. Yeah. Yeah. Then like you can assume that like it is something like called in memset. Yeah. And then in lib string the C, so like that's not the code that you wrote. But it says it's called from page lock and current pmap the C 351. Yeah. Then let's try to check like what code this is. So from the stack it says these information, and then if you're curious about like more about the stack, then if you run bt, then it's actually backtrace. So now we crash at memset, page lock, meminit, i388 relocated. So this kind of information is very helpful for like that right now we know that where this memset is called, and then it kindly let us know about the current pmap the C 351. And let's go there. Pim current pmap the C, then line number 351. Oh, there's a memset. Yeah. So GDB is very convenient too. So whenever you encounter triple fault, just turn on GDB and attach it, continue. Then it will stop at the address with fault. Then how can we resolve this fault? Then now we know that the memset is called in the page lock. Let's go to the GDB tab. Yeah. Then what about like what kind of arguments? Oh, so it also shows us like what kind of the address, set value, size is supplied for like the memset. And the function was we were like the page size 4096, 0 as a second argument, 0 here, and then it means like so what we put is like the page to PA here is like just to allocate the one of the page. Yeah, to allocate the one of the page, we cut off the page free list. Yeah, and then so we cut off the page free list and then return make it as a 0. But important thing here is that in this memset, because we are in C language, all the addresses are virtual address, and we enable paging here, right? So this address must be virtual address, but I intentionally used the physical address to generate the triple fault. And even if you don't know this kind of information, then just to briefly know about all the addresses need to be virtual. Then take a look at this. You called memset target memory address as 3FD000. Is that a virtual address? No, virtual address must start with F something in JOS. F0103CD. This is definitely a virtual address because it's over current base, right? But this address is not a virtual address. So there's a crash, and actually the instruction says, EAX store to EDI something. Yeah. And then EDI points to this 3FD00, the physical address. So what it does is like it stores EAX, 0 value, yeah, to the address pointed by EDI here. But it's a physical address, not the virtual address like this. That's why it gets error. So now we know the answer. So that was not a virtual address. That's why it has an error. And then we know how to change it. Maybe it should be page 2 KBA or KADDR page 2 PA. Either one would work. Wrap it, then it'll be a virtual address. Then let's check if that actually changes to the virtual address. So what we will do is like we will set the breakpoint at the current PMAP to C and 351. Make, and then go to GDB, make QEMU, GDB, GDB here. And then reset on GDB in current PMAP C 351. And then set the breakpoint and continue. Then now we stop that here, yeah. And then let's get into memset. Let's run until, yes, now we are called memset, right? Then let's take a look at arguments. Now we have F0, 3FD000. Yeah, this is a virtual address. So that actually resolved the error. So if we continues, then it says page unlock succeeded. And the reason why I stop it here again is like it is a breakpoint at here. So remove the breakpoint and continue. Then all the things now will be succeeded. That means now you can run, make grade, and pass it all. So we just go over like how you can resolve the triple fault. So first thing, please, whenever you see triple fault, turn on GDB and attach it, and then continue, and then get the backtrace information, and then try to understand the source code, assembly line, backtrace, locate where your error is. And if you want to ask some of the questions about the triple fault, please do this step first, and then please set. So if you even if like after getting this information and do the debugging, if you still cannot resolve the issue, then please ask a TA question with the copy and paste of those kind of information, because that will reduce a loss of time for TAs, and you will learn lots of things while you are actually doing debugging. So please use GDB and have fun.